We are on the eighth lesson on paper two, and this time we're going to be talking about elimination reactions. Okay, so an important thing to know about elimination reactions is that one, they are reactions where atoms or groups of atoms are removed from an organic molecule. So remember, in the previous lesson, we talked about addition, and there we were adding atoms or groups of atoms, right? And here we are now removing the atoms from the organic molecule. And then when this happens, you can either form a double bond or a triple bond. So normally our starting molecule is a carbon with only single bonds. So remember, so meaning we are moving from saturated compounds to now unsaturated molecules. So remember, with respect to addition, we were adding atoms to unsaturated compounds which are double or triple bond that have double bonds or triple C bonds to saturated. Here we're moving from C single bonds to either a double bond or a triple bond. And in this lesson, we're primarily going to focus on double bonds, which we now know are alkenes, right? So, without wasting any time, let us just get straight into it. So, also another important thing, it's very important to understand that elimination is basically the opposite of addition. So, if you understand addition, it's going to be much simpler for you to understand to understand elimination. So, the first reaction we're going to consider, it is dehydrohalogenation. Dehydrohalogenation. And what happens here? So it's dehydrohalogenation of haloalkanes. I'm lying. Of haloalkanes. So what normally happens is that this D means we're gonna be removing. So we remove either chlorine, Cl2, or Br2. What's the other one? Iodine, whatever. What's the other one? I forgot the other one. Or F2, right? So that's the thing. So we're gonna remove those. Remember, these are halogens. You find them in group 7 of your periodic table. And then in this instant, so let us just do it. You find that you will either form a major product or a minor product. So let us see. Let us say we start with a, let me remove this, it's not necessary. So let us say we start with a molecule such as this one. And then we have your hydrogen. Let me quickly draw this. And then here, let's see, we can have chlorine, right? So this is a haloalkane. And we are dehydrohalogenizing it in a sense. So we want to remove this chlorine as well as this hydrogen, right? So what do you think is going to happen? So you notice one thing, where will the double bond form? So to determine where the double bond will actually form, we have to now consider that it can either form here or here, right? So we have to have a major product. Remember, in the previous lessons, we've already spoken about major and minor products. So sometimes in a question, you are asked to write down the major product or the minor product. So so we know that we want to remove hydrogen or chlorine. So now there's a rule that you have to say. And that rule, it's called, I don't know how to pronounce this name for peace sake. But then what this rule tells us is that the hydrogen will be removed from the carbon atom with the less number of hydrogen atoms. Let's start again. The hydrogen will be removed from the carbon atom with the least number of hydrogen atoms. So meaning we're going to be comparing these two carbons here. So you can either remove this hydrogen or this hydrogen, right, from this carbon. So between these two, which one has the least number of hydrogen atoms between these two? So here we have 1, 2, here we have 1, 2, 3. This one has the least number of hydrogen atoms, and we also know that we will be removing this. So to form the major product, we will remove the hydrogen from this carbon. So what is that telling me? The double bond will actually form here. So in this case, it means that we will have a double bond there at the second carbon from your right. So we have 1, 2, 3 hydrogen. So remember, we removed the chlorine atom, H. We've also removed the hydrogen atom. And there we are. We have somehow formed the double bond there. For a minor product to form, it means that the hydrogen will be removed from the carbon atom. It's raining. I hope it's not going to affect the sound. But meaning that the hydrogen atom is going to be removed from the carbon with the most number of hydrogen atoms. So we're still comparing the two carbons here. So it can either be removed from here or here. This is the carbon with the most number of hydrogen atoms. So if we remove this hydrogen in this regard and this chlorine, the double bond is going to form there instead of here. So the hydrogen will actually form on the first carbon, if we're counting from, no, this is a lie. So we have 1, 2, 3, 4. So here we have removed the chlorine atom, and here we have removed the hydrogen atom. So we have H, 1, 2, 3, 4, and then there we are. 1, 2, 3. C. So please note that difference. When is it that we form a major product, and when is it that we form a minor product? So remember, with addition reaction, we used Markovnikov's rule, and you have to know how to form major and minor products. So now let us take the second type of elimination reaction. But before we do that, I forgot another important thing in terms of these reactions. You have to also know some reaction conditions. And with this one specifically, they're saying that this reaction has to take place in the presence of concentrated sodium hydroxide or potassium. So NOH, KOH, in the presence of concentrated sodium hydroxide or potassium hydroxide in ethanol as a solvent. So those are some of the things you might be asked a reaction, a reaction condition for dehydrohalogenation. So you also have to know that. And then, like I mentioned, the second reaction that we're gonna consider now is dehydration, where we remove the water molecule. So what is this telling us? So if we're removing H2O, it means that we are actually starting with an alcohol. So let us say we had this alcohol, it's butanol. I'm trying to draw this as fast as I can because I hate for these videos to be longer than they need to be. So we have an alcohol. We have an alcohol which is butan-2-ol. I hope by now you know how to actually name these alcohols, butan-2-ol. And then we are removing hydrogen. So we're removing a water molecule. So remember, still in this case, we can form major and minor products. So we start with a major product using that rule, and a minor product. So to form a major product, they saying, so we know that we're going to remove this OH, right, as well as the hydrogen. So you can either remove this hydrogen or this one. So how do we know which hydrogen to remove? In that case, that's when we have a major product and a minor product. So you're going to be comparing between these two carbons here. So a double bond can either form here or there. And according to that rule, remember, to form a major product, they're saying that the hydrogen atom will be removed from the carbon atom with the least number of hydrogen atoms. So if we compare these two carbons here, this is the one with the least number of carbon atoms. So what is that telling me? This means that the double bond will actually form here, because we will remove this hydrogen and this OH and then develop a sort of a double bond over there. So then you have a double bond like that, right? So we've removed the OH, we've removed the H there, and this is what we left off. So you seeing that we're moving from a saturated compound to an unsaturated compound or molecule. But then for the minor product, we will remove the hydrogen from the carbon atoms with the most number of hydrogen, comparing these two carbons here. Hydrogen, we remove it from the carbon atom with the most number of hydrogen. So we'll remove it here. If you remove this hydrogen as well as this OH, this means the double bond will sort of form here at the first carbon. So meaning we'll have something like this. And then, so we've removed the hydrogen there, we are only left with two. We've removed the OH there, and here we just left with our hydrogens. So you see that we moved from an alcohol, in that case it was butane 2-ol, to an alkene. So this would be butane, but2-ene, right? If we start labeling from this side, doesn't really matter. We can also label from the other side. The same thing here, right? Okay, I hope that is clear. So now let us move to the third type of elimination reaction that you're supposed to know. But before we do that, it's also very important for you to, like I mentioned before, the reaction requirements. For this reaction to take place, for us to remove water. So remember, it's also important, before I move on, that water will be released. So we have plus H2O. So you form your alkene plus H2O, your alkene plus your H2O. But then now talking about the reaction conditions. So for this type of reaction, you need to actually heat your alcohol with a concentrated acid. So that acid, normally it is H2SO4, that is sulfuric acid. So those are some of the things that you actually need to know. So now let us move on to our third type of elimination reaction that you need to know. So the last elimination reaction that we're going to be talking about is cracking. And there are many others, but with reference, because we're using our examination guidelines, that is what telling us what is it that we should know and what is it that we don't know. So it sometimes becomes unnecessary for you to study certain reactions when they're not actually going to be assessed. So according to our examination guidelines, we have to know these three types of elimination reactions that we're doing in this video. And what is cracking? So this is a very interesting process. It is when it's a chemical process in which very large chain or hydrocarbon chain molecules are broken down into shorter, more useful molecules. So in a typical cracking reaction, you'd find that you form an alkene as well as an alkane, right? And there are two, can differentiate between two types of cracking reactions. There's thermal cracking and there's catalytic cracking. I'm going to define what each of those is just later on in this video. So let us take, for example, that we had a very extensively long hydrocarbon here, H. So there we were. Let's say, I'm gonna just quickly draw this. So in here, in this instance, we had a very long alkane, and then we want to break it into more useful into more useful molecules that we can use. So we're gonna break it down through this process of cracking. So we can either use thermal cracking or catalytic cracking. So when we break this molecule, you find that this maybe you break it and then you form an alkane. You can form either an alkane. So there are about 6 carbon atoms here. So we form an alkane. A shorter molecule plus an alkene. So what are you noticing from this hexane? So we started from hexane, which was a long molecule, and we broke it down into propane and propene. So it's a very useful process in terms of breaking very large molecules, right? And then I said that we're going to talk about how do we then differentiate between two processes of cracking. There's thermal cracking and there's also catalytic cracking. So for thermal cracking, what you require is that you're using very high pressure and high pressure, not higher. High pressure, what did I write here? High pressure as well as and high temperature to crack the long hydrocarbon. So here there is no catalyst used. So to break down that large hydrocarbon or that large hexane molecule, we might use thermal cracking, where we use the very high pressure, expose our molecule to very high pressures and high temperatures. Don't know why I didn't write high temperatures, right? Or catalytic cracking, where in this case we are using a catalyst to break down that long carbon chain. And here is that we're using a catalyst, right? Catalytic. So it's catalytic cracking, where we're using a catalyst. And additionally, the thing is that here this reaction occurs at very low temperatures and low pressures. So those are some of the things that you need to know and be able to answer questions on, right? And yeah, this actually brings us to the end of this lesson.